Hi guys, this is Rekha from Edureka. I welcome you to this session on predictive analytics using R. Without any further delay, let's take a look at today's agenda. So guys, we're going to begin this session with an introduction to predictive analytics. Alright, we'll see what exactly predictive analytics is, and then we'll move on and discuss the various stages of predictive analytics. Next, we'll look at how predictive analytics can be implemented using R. Here we'll also see what are the features of R and why you must choose R. Alright. After that, we'll move on and look at a real world use case. And then we'll finally end this session by looking at a demo where we'll see how predictive analytics can be used to solve a real world problem. Alright, so guys, I hope all of you are clear with the agenda. Now let's move on and get started with our first topic. So guys, what is predictive analytics? Now, predictive analytics refers to using historical data, machine learning, and artificial intelligence to predict what will happen in the future. Alright, to simply put it, it answers the question which is what is most likely to happen based on current data and what can I do to change that outcome. So it basically tries to predict the future by studying the present data available. Alright. So how the process works is the historical data is fed into a mathematical model or into an algorithm that considers key trends and patterns in this data. The model is then applied to the current data to predict what will happen next. Alright, so it will predict an outcome. So guys, predictive analytics is something that these top tier companies implement so that their business or their revenue grows. So guys, analysts can use predictive analytics to foresee if a change will help them reduce risk, improve operations, or increase revenue. Now let's move ahead and talk about the different stages of predictive analytics. So guys, predictive analytics always involves a business problem that needs to be solved. You also have to have data that needs to be prepped for analysis, models that need to be built and refined, and finally to retrieve the predictions and convert them into positive outcomes. Predictive analytics project will involve these 7 steps. So the first step is define your problem statement. Now, before you even start on a project, it is very important that you understand the problem you're trying to solve. Alright, so in this stage, basically, you're going to identify all the objectives of your project by identifying the variables that you need to predict. Once you're done with that, your next stage is data collection. So after you've defined the objectives of your project, it's finally time to start gathering all the data. Right, at this stage, some of the questions that you can consider is what data do I need for my project? Where does it live? How can I obtain it? And what is the most efficient way to store and access all of the data? Alright, so this phase involves collecting all the data. It might be data stored in a database, or you might actually have to go out, do some research, and then collect data. Once you're done with data collection, the next step is data cleaning. So guys, like I said, usually finding the right data will take you both time and effort. Okay, so if the data lives in a database, then your job is very simple because all you have to do is you have to query the relevant data using SQL queries. But if your data doesn't actually exist in a data set, you'll have to scrape it. Now, this is where you transform your data into the desired format so that you can read the data. Alright, so once you've collected the data, you need to transform it into a format so that it can be readable. So once you're done with the transformation part, you move on to the most time-consuming step, which is called cleaning and prepping the data. Now, this is especially true in big data projects, which usually involve terabytes of data to work with. So when I'm saying cleaning the data, I mean that there are a lot of missing values or a lot of redundant values in your data set. You need to get rid of all of these inconsistencies so that you can predict your outcome correctly. Now, next stage is data analysis. To define data analysis, it is a process of transforming, inspecting, and modeling the data. Alright, so the main goal or the main aim of this process is to discover useful information. So what you do in this stage is you evaluate all the variables that are available to you or all the data that is available. You understand the construction, you understand the population, the quality, and the relationship among the different variables and the different data. And then you retrieve useful information from this data. So basically, this is where you understand all the patterns that are hidden in your data. To do this, you can also pull up and analyze random subsets of data by plotting a histogram or by creating an interactive visualization. All right. So basically, you have to dive down into each data point and you have to explore and understand the story behind the data. All right. This is where you retrieve all the useful insights from your data. So what do you do once you've retrieved all the useful insights from your data or the useful patterns from your data? You begin to form hypotheses about your data and the problem you're tackling. All right, now the next stage in predictive analytics is building a predictive model. So guys, building a predictive model involves mapping your data into a machine learning algorithm. Machine learning algorithms can be used to solve a series of problems, whether it is a classification problem, regression problem, or a clustering problem. So the first step to building the model is to split the input data randomly for modeling into training data set and into testing data set. After that, you will build the model by using the training data set. Okay, so this is basically building the predictive model. Next step is validating the model. Now, once you've built the model, you have to test the accuracy of the model, or you have to test how efficiently the model is predicting your outcome. Now, how do you do this? You can do this by using the testing data set on your model, and you can evaluate whether the predictions are accurate or not. So guys, at this stage, you must try and improve the efficiency of your model by filtering out the response variables that can help you predict the resultant variables. So guys, many a times there are like hundreds of predictor variables which aren't actually helping to predict our outcome variable. So what you do is you filter down a set of predictor variables which will highly affect the outcome of your resultant variable. Alright, so you're just going to filter down the most important variables in your model. Now the next stage is the deployment stage. So guys, the goal of this stage is to deploy the models into a production or a production-like environment for final user acceptance. Alright, the users have to validate the performance of the model, and if there are any issues or any redundancies, then it has to be fixed in this stage. So guys, that was all about the stages in predictive analytics. So in our demo, we'll be discussing each and every stage. We'll be implementing it using the R language. Okay, so now let's move on and look at our next topic, which is languages for predictive analytics. There are a lot of languages that you can use to implement predictive analytics. We have Python, we have R, we have MATLAB, we also have Java. So guys, there's a reason why I chose R for this tutorial. Let's look at why we should go for R, and let's discuss a few features of R. So to begin with, R is an easily understandable language. Alright, it has a very simple and flexible syntax. So the next feature is that it is a programming and statistical language. Now guys, when it comes to processes like predictive analytics or fields like data science, a statistical language is very important because all of these processes involve a lot of math, a lot of statistics. Since R is a statistical language, it is very useful in such processes. Now, the next feature is data manipulation. With R, you can easily shape the data set into any format that could be easily assessed and analyzed by slicing large multivariate data sets. Okay, so data manipulation is something that is easily done in R. The next feature is that R has inbuilt functions for data analysis and predictive analytics. So guys, R provides a lot of statistical functions because I mentioned earlier that it is a statistical language. Alright, so it has a lot of inbuilt functions which are already defined. All you have to do is you have to call these functions. So R has over 8,000 plus packages that can be used to implement various statistical analysis tools related to hypothesis testing, model fitting, clustering techniques, and machine learning. Alright, there's several packages that you can install. Okay, so for each of the machine learning algorithms, there's a library. You don't have to code the algorithms. Instead, all you have to do is you have to load these libraries. You don't have to actually sit down and code the entire algorithm. The next important feature is data visualization. So guys, in order to understand a data set and the relationship between various variables, it is very important to visualize the data. And R provides a lot of packages which help with data visualization. Moving on, it has a massive community support. It is the most sought after technology because of its community support. Okay, so there are over 2.5 million users that are using R, and companies such as Google, Facebook, Mozilla, etc. also make use of R. Okay, now let's try to understand predictive analytics with the help of a real world use case. Now the first question here is, what is sports analytics? Now guys, sports analytics includes the use of data related to sports such as the players' statistics, weather conditions, information from expert scouts, and so on to build a predictive model around it to make informed decisions. So what you're going to do here is you're just going to study the data about each player and you're going to predict how well the player is going to play, or how well the player plays during particular humidity conditions or weather conditions. A lot of things can be done using sports analytics, and this is actually implemented in real world sports right now. People who've watched the movie Moneyball, all right, that was all about sports analytics, and it was all about how you can use predictive analytics in order to make better decisions about the game. Now that we have a lot of data available, if predictive analytics is applied to sports, you can actually draw out a lot of useful information from a match. So for example, let's consider the game of baseball. Now the speed of the pitch, the speed of the bat, the ground conditions, the humidity, temperature, all of this data can be recorded for each match. Now, this data might seem useless to a viewer like you and me, but by using predictive analytics, we can process this data and draw comparisons and conclusion about a game. So comparisons like the performance of a player under particular temperature or humidity, or the performance of a batsman against a particular pitch. Okay, so using the concept of predictive analytics in today's scenario, the stadiums are also equipped with special cameras which are dedicated to every player on the ground. Okay, so these high-speed cameras, they record every minute detail from the speed of the ball to the body temperature of the player, and they send this to the server in real time. Then this data can be used to make better decisions or to determine the performance of a player over the series or a season. And these days, we've also been introduced to wearable technologies. So basically, there are watches which record your heartbeat, your perspiration level, your fatigueness, and stress. Now, these kind of devices are also used in sports. Okay, so these devices basically record the heartbeat, perspiration level, and all of that. And they will help the coach to train the players in a better way. Okay, so that they can avoid injuries and all of that. So guys, actually there are a lot of football teams and a lot of baseball teams which follow predictive analytics. Okay, an example of this is Real Madrid. Okay, they practice predictive analytics in order to focus better, make better decisions about the game. All right, now finally let's move on and look at our today's demo. So before we start with the practical part, let me tell you what exactly we're going to be doing in this demo. All right, so the problem statement is we're going to implement predictive analytics using R to diagnose whether or not a person has breast cancer based on past medical data. Now, the data set is collected from the University of California website consisting of breast cancer cases, and we're going to use this data set to build a predictive model that classifies a tumor as either malignant or benign based on certain feature variables. Okay, these are the feature variables. We have a uniformity of cell size, we have uniformity of cell shape, we have marginal adhesion, we have bare nuclei, we have normal nuclei. So there are certain variables that can be used to detect whether a certain tumor is benign or malignant. All right, so we're basically detecting if a person has breast cancer or not. So I hope all of you are clear with our problem statement and data set description. Now, the process or the logic behind this demo is predictive analytics. All right, so we're going to begin the demo by importing data. Then we're going to perform data cleaning. All right, I've spoken about this earlier in today's session. After which we'll build the model and we'll train it using the training data set. And then we'll finally evaluate the efficiency of the model using the testing data set. All right, so this is how we're going to perform this demo. Now, without wasting any further time, let's look at our code. So guys, in order to save some time, I've already typed out the entire code. For those of you who are not familiar with the R language, I'll leave a link in the description. All right, you can go through that content. Don't worry, I'm going to explain each line in detail. All right, so we're going to begin the demo by importing the data. I've already downloaded the data and I've stored it in this path. Okay, it's in my desktop in the predictive analysis demo folder. And this is my text file which contains the data. Then we're going to use the read.csv function to read our data set in a CSV format. All right. So we're going to store this entire data set in a variable called cancer data. All right. So let's just run this line of code. Okay. So we've successfully loaded our data set. Now let's just display the structure of the data set. To do that, there's a function called str in R, which lets you display the structure of the data set. So the output here shows that we have around 698 observations and we have 11 variables or 11 feature variables. Okay, these are our feature variables. Now the problem here with the variables is that the name, they're not labeled in a way that we can understand. Okay, we can't understand what x1 or x2 or x3 stands for. So for that reason, we're going to label the data set. Now, when I took the data set from the website, there was a description about the data set, and that's why I have all of this labeled over here. So this code snippet is just going to label all my variables. Now let's look at the structure of the data set. All right. Now you can see everything here is labeled. Okay, this bare nuclei, there is mitosis, class, bland chromatin, and all of that. So guys, these 11 variables or these 11 predictor variables are used to predict our outcome. Okay, our outcome is to classify a tumor as either malignant or benign. Okay, so we're basically predicting if the tumor is harmful or not. Our next step here is data preparation. If you look at the data structure over here, there is a variable called ID, all right, the first variable. Now this variable is obviously not needed to predict the outcome. Okay, we don't need such variables, so we get rid of such redundant variables. All right, this is exactly what this line is going to do. Now if you check the structure, okay, you can see that we have only 10 variables now because we removed the ID variable. All right. So our next step in data preparation is to convert the data into numeric format. Now, if you look at the variable bare nuclei over here, it's of the type character. Okay, even though these are numerical digits, it's of the type character. So we need to convert it into a numerical value, which will be running this line of code. Okay, so R basically has a function called as numeric. Okay, that will be used to convert a character into a numeric variable. All right, now if you look at the structure of the data set, so initially here there was character. Now if I look at the structure, you'll see that it's number. Okay, so we've converted into a numeric format. Next line of code is going to identify the rows without missing data. So guys, the problem with missing values is they will lead to inaccurate predictions. So our outcome will not be precise if we have missing values in our data. So there's this function called complete.cases, which will check for all the samples that have all the values. All right, so we are just going to use this function and we're going to filter out all the observations which are free of missing values. So earlier we had 698 observations. Now if we run this line of code and if we display the structure of our data set, we have around 682 observations. Okay, so around 6 observations had missing values and we got rid of those missing values. Now next step is basically about this variable called class. So guys, this class is basically a resultant variable. All right, this variable will predict if a tumor is benign or malignant. Okay, so if it's benign, it's going to be labeled as 2, and if it's malignant, it's going to be labeled as 4. Okay, so what we're going to do is we're going to change the labeling of this. Okay, we'll keep it as 1 and 2. Okay, if I run this and if I look at the structure, all right, here you can see that now it's transformed into 1 or 2 and all of that. So once you're done with cleaning and preparing your data set, your next step is going to be building the model. Okay, like I mentioned earlier, the first step in building your model is splitting your data. Okay, data splicing is the process of splitting your data into training set and testing set. So guys, you have to always remember that your training set has to have a lot of data samples when compared to your testing set. Okay, that's because in your training set is when your machine is going to learn. Okay, the more data you feed the machine, the better it's going to learn. So from row number 1 to 477, I've assigned it as a training set. Okay, from 478 to 682 is my testing set. One more thing to note here is I have only added columns from 1 to 9 to each of these data sets. Now the reason behind this is that the 10th variable, which is class, is our outcome variable. Okay, so when I'm training and testing my data set, I don't want to feed the output as well. Okay, I want the machine to figure out the output when I give it the input. I'm basically storing our testing outcomes and our training outcomes over here. Okay, you can see that only variable number 10 is stored in both of these variables. Okay, so let's run this line of code and this one as well. All right, so after splitting, we're finally ready to create the model. Okay, to do this, we load the classification package. Okay, this is our library called class, and we run the key nearest neighbor classification algorithm. This KNN denotes the KNN algorithm. Okay, so what we're going to do is we're going to run this KNN algorithm on our training set and on our testing set. Okay, the test data set is also passed in to allow us to evaluate the effectiveness of the model. Okay, that's where validation of the model takes place. So my value of k is 21, which shows that it's going to take into account the 21 closest neighbors. Okay, I've chosen 21 because that's the square root of the number of training samples. Okay, our training samples are 477 and the square root of that is around 21. Okay, that's why the value of k is 21. Okay, so if I run this entire code snippet, so our model is created over here. We've trained our model on the training set. Now let's look at the predictions that the model made, okay, or the output. So what this denotes is our first sample is malignant. Similarly, second sample is classified as benign. So this is the classification that's happened. Now what we're doing is we're going to validate our model. Okay, we're going to test the efficiency of our model. After we display the output of our model, we're going to perform model evaluation. So here we're just going to cross tabulate our test outcomes and our predictions. So we're basically comparing our actual results to our predicted results. All right, so let's run this line of code. Okay, so if you see that 160 of the samples have been correctly sampled as benign, and similarly 45 of the samples are correctly labeled as malignant. Okay, so our predictions are 100% accurate. Now to show you the accuracy, we can run this code snippet. Alright, so your actual value for sample number 1 is 2. Okay, meaning that this is malignant. Okay, when you predicted it, you correctly classified it as 2. Similarly, your second sample is in the class 1, and in your prediction, you correctly classified it as class 1. So we've created a model with 100% accuracy. Alright, so guys, all of this can be accomplished using predictive analysis. That was it for our demo session. If you have any doubts regarding our today's session, please leave them in the comment section and we'll get back to you at the earliest. So guys, thank you so much for watching this video. Have a great day.